All right, welcome ladies and gentlemen. This is our first video for our bonding unit. You are going to need your notes out, open to the first page, page 1, and you're also going to need your reference table opened up to the periodic table. And in this video, I'm going to be talking about valence electrons, Lewis dot diagrams, and the octet rule. So valence electrons, we've seen this before. Valence electrons, by definition, are the outermost electrons. They're the number of electrons in the last energy level, the last shell. And there's a very easy way to determine the number of valence electrons an atom has, an element has. You simply find the group number, and then you take the last digit of the group number. So basically the very last digit of the group number will be the number of valence electrons. So what I mean by that, group 2, all the elements that are in group 2, they have 2 valence electrons because the last digit in 2 is 2. Group 13, every element in that group will have 3 valence electrons because the last digit in 13 is 3. So yes, you can absolutely go and look at your reference table. I'm not saying that you can't go look at the electron configuration, take the last number, but you know, if you're doing this quickly and you don't have your reference table, if you just find the group number, then the last digit of the group number is the number of valence electrons. So for example, how many valence electrons are in each of the following elements? Calcium, Ca, we find calcium on the periodic table. Calcium's right there. Calcium's in group 2, so therefore calcium has 2 valence electrons. Next is nitrogen. We find nitrogen on the periodic table, non-metal. Nitrogen's in group 15, which means nitrogen will have 5 valence electrons. Next up is tellurium, Te. We find Te on the periodic table, atomic number 52. Te's right there. Te is in group 16, which means tellurium has 6 valence electrons. And last is krypton. Krypton's a noble gas, so that means that krypton's in group 18. 18, last digit of that is 8, so krypton has 8 valence electrons. 8 valence electrons. Next up, electron dot diagrams, also sometimes known as Lewis structures, also sometimes known as Lewis dot diagrams. We kind of have lots of ways to say this. These are diagrams that only show the valence electrons of an atom. So instead of drawing all of the electrons like you would in a Bohr diagram, you are only showing the valence electrons because these are actually the electrons that are involved in bonding. So these tend to be the most important electrons, just the valence electrons. And the way that you draw an electron dot diagram or a Lewis dot diagram, is you start by drawing the element symbol nice and big. So for this example, if we're drawing carbon, we would draw a C nice and big right here. And then you would only show the valence electrons. And you show the valence electrons as dots. And you locate the dots at the 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock position. So basically top, bottom, left, right. So carbon, as you can see here, carbon has 4 valence electrons because it's in group 14. So we put a dot at the top, bottom, left, and right. And we will start pairing them up. So as soon as we have more than 4 valence electrons, then we'll have a pair of electrons in each position. But the thing is that you don't start pairing up the electrons until you've placed 1 dot in each of the 4 positions. So for example, I would not draw carbon like this with its 4 valence electrons. No, we don't draw it like that. You would draw it as one top, bottom, left, right, spread them out until you have more than 4, and then you go back and start filling them in. So for example, if we want to draw the electron dot diagram for these 3 elements, first we need to determine their number of valence electrons. So we start by finding them on the periodic table. First up is bromine. Bromine's a halogen, which means it's in group 17, which means it has 7 valence electrons. So if I want to draw the Lewis dot diagram for it, I'm going to draw the symbol, element symbol, nice and big. And then I'm going to go top, bottom, left, right, place 1 electron in each position first, and then go back and double it up. So 1, 2, 3, 4. But then I need 5, 6, 7, so I'm going to go 5 and 6 and 7. And it doesn't really matter where you leave the single one. You could leave it on the top, on the right side, or on the bottom. That doesn't really matter. That's not the important bit. The important bit is that you have the 7 valence electrons represented. Next up is potassium. We want to draw the Lewis dot diagram for potassium. So we find K on the periodic table. It's right there. It's group 1, so it only has 1 valence electron. So I'm going to draw the element symbol, and then I'm only going to place 1 dot. You could honestly put it anywhere at either of the 4 positions, and that's fine. I'm going to put it on the top. You can put it on the left. You can put it on the right. And then lastly, germanium. Ge. So we start by finding it on the periodic table. Germanium's right there. Germanium is in group 14, which means that it has 4 valence electrons. So I'm going to have the element symbol, and then I'm going to go top, right, bottom, left. 1 electron in each of the 4 positions. And those are the Lewis dot diagrams. Next up, octet rule. The octet rule is a really important rule in chemistry. The octet rule says that elements will bond so that they can have 8 electrons in their outermost shell. There is something very important about having a complete octet, because octet means 8. Octa, like an octagon, this prefix octa or oct means 8. So octet rule, we're talking about having 8 valence electrons. The 8 comes from the combination of the s and the p subshells, because there are 2 electrons in s and there are 6 electrons in p. So if both s and p are full, then we have 8. But 8 is sort of like a magic number in chemistry, where things become stable if they have 8 valence electrons in their outermost shell. The noble gases have 8 valence electrons, so they don't have to do anything to get to 8. They're already built in. So every other element on the periodic table has kind of what is called noble gas envy. They want to be like the noble gases, and they're going to gain or lose electrons until they get to 8. So metals. Metals will lose electrons to form cations because they have 1, 2, and 3 valence electrons. They have fewer than 4, so it's easier for them to simply shed their outermost electrons, lose them, because they'll have 8 in the next row down. So for example, group 1, how many electrons will it lose to get to 8? Well, group 1 only has 1 valence electron, right? So instead of gaining 7 to get to 8, they will simply lose their 1 to get to 8. So group 1 loses 1 electron. If they lose 1 electron, they get rid of 1 negative charge, which means that their charge in their ion will be +1, right? They lost an electron, just 1 electron, so their charges will be +1. So group 1 forms like K+, Na+, Li+. Group 2 will again be losing electrons to get to 8. They have 2 valence electrons, however. So instead of gaining 6 to get to 8, they're going to lose 2 to have their outermost shell be sort of the next one down, and that'll be full, and that will have 8. So they're going to lose 2 electrons. Each electron is negatively charged, so their charge will be +2, Mg2+, Ca2+, Be2+. Non-metals. Non-metals on the other side of the periodic table, these guys have 5, 6, 7 valence electrons. So instead of losing 5 to get to 8, they're going to gain 3 to get to 8. Or losing 7 to get to 8, they're only going to gain 1 to get to 8. So because they're closer to having a full octet, they're not going to try to lose their valence electrons. They're actually going to keep them, and they're going to try to add on more to get to 8. So these guys are going to form anions. So group 17, for example, how many electrons will it gain? Well, group 17, 7 valence electrons. They want to get to 8, so they're only going to gain 1. They're going to gain 1 electron, so their charge is going to be -1. So F-, Cl-, I-. Group 16, these guys have 6 valence electrons. So they're 2 away from having a full octet. So they have 6, they want to gain 2 to get to 8. So gain 2 electrons, each electron is negatively charged. Their charge is going to be -2. So O2-, S2-, Se2-, etc., etc. So that's the end of the first video, and we'll be working with this in class tomorrow.